Now, here's what I'm going to ask you to do. Yes. What I would like to do in your groups, you guys, is I want you guys to all work together to come up with one definition. A working definition for what it means when I say the greatest common factor of two or more numbers. So we'll let people in position number 3, you will be the recorders. You're going to write the definition down. You can write it down on your whiteboards. So position number 3. Okay? Since you guys don't have a 3, it'll be you. The rest of you are contributing your ideas. I'm going to give you about 5 minutes to come up with your idea of what is the greatest common. Okay, so really good work on greatest common factor, you guys. As we explored it, you guys, when we're talking about the greatest common factor, the definition of greatest common factor is a whole number that is a factor of 2 or more whole numbers that is the largest of the set. This is in your notes. Write this down. Just like you see it. Okay? So the greatest common factor is a whole number that is a factor of 2 or more whole numbers. That is the largest of the set. So the examples there, we have 12, we have 9. The factors of 12 are 1 and 12. 2 times 6 and 3 times 4. The factors for 9 are 1 times 9 and then 3 times 3. So here, the set for 12 is 1, 2, 3, 4, 6, 12. The set for 9 is 1, 3, 9. What is the largest number that is the same between the two numbers? It happens to be the number 3. Okay? Now, we're going to explore in just a moment what it really means to find the greatest common factor, what you're really doing to find the greatest common factor. But what I want you to do is I want you to write down these steps. Now, it says, what is the greatest common factor of 12 or 24 and 48? So write this in column 3. What is the greatest common factor of 24 and 48? Now, step number 1 is simple. Step number 1, you're just going to rewrite each number as a product of prime factors. It's what we did on Friday. Okay? You're going to rewrite each number as a product of prime factors. So you're going to do factor trees for the two numbers. So if I take the number 24, and then I take the number 48, and I'm going to rewrite it as a product of prime factors, I'm first going to break down 24. There are many ways I can go. I could say 2 times 12. I could say 3 times 8. I could say 4 times 6. So I'm going to say 3 times 8. 3 is prime. Now 8 is 2 times 4. 2 is prime, and 4 becomes 2 times 2, and 2 is prime, and 2 is prime. Then 48, again, many different directions I can take. I can take 6 times 8 is 48. I could say 4 times 12 is 48. I could say 2 times 24 is 48. But I'm just going to take 6 times 8. 6 is composite, so I'm going to break it down into 2 times 3. 2 is prime, 3 is prime. 8 is 4 times 2, 2 is prime. And 4 is 2 times 2, which 2 is prime and 2 is prime. Okay, write that down quickly. All right, now step number 2. After you have listed, you're going to list the prime factors in order from least to greatest. You're going to list the prime factors in order from least to greatest. So here, for 48, I had 2 times 2 times 2 times 2 times 3. For 24, I had 2 times 2 times 2 times 3. So I just listed the factors. The circled numbers, I list them in order from least to greatest. Now, in your discussion, you guys, we spent a little bit of time talking about should the greatest common factor, the answer, be bigger or smaller than the numbers we're working with. And you guys came up with the conclusion that the greatest common factor should either be smaller than both numbers, or it could be the same as the smaller number, correct? So we'll talk about that in just a minute. Now, step number 3. Okay, step number 3. Circle all the common factors that appear in both numbers. So here, I see a 2 and 48, I see a 2 and 24. I see another 2 and 48, another 2 and 24, another 2 and 48, another 2 and 24, and then I see a 3 in both numbers. There's an extra 2 and 48, but I don't need to worry about that because doesn't have an extra 2 at the bottom. So I circle all the common pairs. Notice how I circled them though. One has to be on the top and the bottom. Okay? Okay, step number 4. Okay, step number 4. Step number 4 says multiply the pairs. But you guys, pay attention to this. Put your pencils down quickly. Don't write it yet. I want you to watch it. You take the pairs. You guys ever play cards like Go Fish? Yeah. And you say, do you have any 2s? And they say, oh, here you go. You take the 2s and you put one on the back, right? And you hold it and then you put them down as one pile. The same goes here. I'm going to take the 2s and combine them into 1. I'm going to take the 2s and combine them into 1. I'm going to take the 2s and combine them into 1. I'm going to take the 3s and combine them into 1. Then I multiply. 2 times 2 is 4, and I bring a 2 down. 4 times 2 is 8. I bring the 3 down. 8 times 3 is 24. Okay? So, right, quickly. Yes.
Do we do our next page?
Here's an example of where you would use the greatest common factor. Everybody read it with me. Okay, so it says there are 36 girls. Ready? Read.
There are 36 girls in Mr. Dixon's Mr. Packer's class. There are 24 boys in our class. We don't make groups of girls and boys to complete a project. We want the same number of girls in each group. We want the same number of boys in each group.
Okay, so now let's just.
What is the biggest number of girls and boys
Okay, so here would be one group of students. Now here, I would have boys and I would have girls in the same group. You guys understand that from the context of the problem? And then here would be the second group, and here would be the third group, and it would keep going on, right, until I ran out of students. But it's saying in the problem that they want the same number of boys in each group. And it's also saying in the problem that they want the same number of girls in each group. So I don't know how many boys would go in the groups, and I don't know how many girls, but I want to know what is the greatest number of girls and what is the greatest number of boys that I can put into each group. If I have this huge group and I'm breaking it into parts, what operation is that? I'm dividing it. I could subtract it, right? To take a big number and get smaller, I'm using the division or multiplication. But here, I'm going to have to divide it by the same number, correct?
Correct.
Now, if I take a number such as 36, and let's say I divide it by 6, and I get 6 to make 36, and I have 0 left over, I just wrote 2 factors for 36, didn't I? But I used the operation of division, correct? So, if I looked at the number 12, let's say, and I divided it by 4, and I got 3 times 4 is 12, what did I just come up with for the number 12? 2 factors. And what are the 2 factors of 12 that I just came up with? 3 and 4. So here, it says, what is the greatest number of girls and boys that can be in each group? Okay, so take out your whiteboards quickly and quietly. Let's solve this problem together. Okay. So this is what it is asking. I want to know if I take 48 girls and 36 boys and I divide them by the same number, by the greatest common factor, this will be how many kids will be into each group, correct? So step number 1, according to our notes, was you're going to take your 2 numbers and rewrite them as a product of prime factors. So everybody right now take 48 and 36, and we're going to do factor trees for those 2 numbers. We're going to break them down into its prime factor form. So, for 48, everybody write 6 times 8 under 48. 6 times 8 equals 48. Take 6 and break it down into 2 times 3. 2 is prime, 3 is prime. Now 8, take 8, and it's 4 times 2. 2 is prime, 4 becomes 2 times 2. 2 is prime, and 2 is prime. Okay, now take 36. Now 36 is 9 times 4. Everybody take 9 times 4 is 36. 9 is composite because I can break it down into 3 times 3. 903 is prime. 903 is prime. 4 is 2 times 2. 2 is prime. 2 is prime. Now, step number 2 says you take your prime factors and order them from least to greatest. So I'm going to take 48, and I have 2 and 3 and 2 and 2 and 2. So 1, 2, 3, 4 2s and a 3. So 1, 2, 3, 4 2s and 1 3. Then I'm going to take 36. Now 36 is 2 2s, he said 2 2s, and then 2 3s. So 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. Now the next step, it says circle the common prime factors. So I have a 2 on top and a 2 on the bottom. I have a 2 on top, a 2 on the bottom. I have a 3 on top and a 3 on the bottom. I've circled the common factors. In 48, I have a 2 and a 2 left. I don't have any 2s on the bottom. I have a 3 left on the bottom, but I don't have any 3s left on the top. Remember, it has to be a 1-to-1 correspondence. It has to be on the top and the bottom in order to be able to circle it. Now the next step, it says you're going to take your pairs and just write them one time. Like cards, right? You're putting them together. So I have a pair of 2s, I write 2. A pair of 2s, I write a 2. A pair of 3s, I write a 3. And then multiply. What is 2 times 2?
4.
So now what is 4 times 3? So my greatest common factor is 12. Now, if I take 48 and I divide it by 12, what is 48 divided by 12? 4. If I take 36 and divide it by 12, what is 36 divided by 12?
3.
That means in every one of my groups, I am going to have 4 girls and 3 boys.
That's 12.
Okay? Everybody got it?
I did 3.
Where you how to get 3?
Oh, wait, no. I did.
Okay, let's practice.
Can we do it on our own?
I want to know what is the greatest common factor between 9 and 12. 9 and 12. What is the greatest common factor between 9 and 12? First of all, prime factorization, right? So I'm going to take 9 and I'm going to take 12. I'm going to break 9 down into 3 times 3, correct? 3 is prime, 3 is prime. Now 12, I can say 6 times 2. I see 2 is prime. 6 is 2 times 3. 2 is prime, 3 is prime.
I put 3 times 4.
Now, list your factors in order from least to greatest. So 9 is just 3 times 3. 12 is 2 times 2 times 3. Circle the pairs, common factors. I have a 3 on top and 1 3 on the bottom. There's no 2. This is 3 times 3 and this is 2 times 2 times 3. I combine the pairs into 1. That's all there is, just a 3. What's my greatest common factor?
3.
3. So my GCF equals 3. Okay, next one. Here we go. Erase your boards quickly. Try this one with me.
Wait. My marker is not
What is the greatest common factor between 18 and 24? Okay, first step is what? What's my first step? Factor trees. Take 18, take 24. 6 times 3 is 18, 3 is prime. 2 times 3 is 6, 2 is prime, 3 is prime. 24, we say 2 times 12 is 24, 2 is prime. 4 times 3 is 12, 3 is prime. 2 times 2 is 4, 2 is prime, 2 is prime. Now list your factors in order from least to greatest. I'm going to take 18. I'm going to make it 2 times 3 times 3. I'm going to take 24, and it's going to be 2 times 2 times 2 times 3.
Thanks.
Circle pairs. I have a 2 on top, 1 2 on the bottom. I have a 3 on top, a 3 on the bottom. Like that, right?
So you have 2 2s.
So this is 2 times 3. What is 2 times 3?
6.
So my greatest common factor equals 6.
These confusing me so bad. Me too. Eraser has enough ink.
Okay. If you would please. Okay, last example I'm going to show you what we're going to do together, and then you're going to start doing it on your own. Okay, 54 and 15. Okay. Okay, first step, prime factorization. Do it, go. Prime factorization for these two numbers, go.
In fifth grade, some teacher said put a box around the deposit number. Oh!
Okay, so after you wrote 54 down, you should have had 2 times 3 times 3 times 3, and then 15 is 3 times 5. The only common factor is a 3 between those two numbers, and so the greatest common factor is 3. Okay. You know, I said we're going to do, that was the last one, but we're going to do one more. Erase your boards, here we go, last one. And then we're going to practice on our own. Okay, I want to know what is the greatest common factor between 8 and 27. Step number 1 is prime factorization. Take 8 and take 27 and break it down into its product of prime factors. 8 we know is 4 times 2. We know 2 is prime, 4 is even, so it's got to be broken down into 2 times 2. 2 is prime, 2 is prime. 27, I know I take 3 times 9 to equal 27. I see I have a prime number in 3, and 9 is 3 times 3. Circle the 3's. So 8 equals, it's 2 times 2 times 2. 9 equals 3 times 3 times 3. Then I'm going to circle my common factors. What do I notice about this number? There is no common factor. But we learned when we talked about factors is what is the first factor that every number has in common? Number 1. So here in this example, since we're not circling anything, what is the greatest common factor? 1. So here, the GCF is going to just equal, oops, 1. That's not like a really funny face. No, that's what it looks like. It's 1. Okay?